button matrices are often hard, blocky, and uncomfortable to put in a wearable. That's what led us to develop a more textile-friendly alternative, a truly soft button matrix. 3D printing on stretched fabrics create dynamic 3D shapes, which we explored to develop a series of buttons. They print flat and transform as the fabric de-stretches. Different geometries impacted the on-body feel and tactile feedback differently. This was explored to create a reliable, comfortable, aesthetic button. In order to measure the buttons, an embroidered circuit with conductive yarn was made to read when a button is pressed. Circuit pathways are embroidered to create open switches that can be closed with a conductive material to create a successful connection. A frame and jig were created to reliably combine the 3D printed and embroidered layers, keeping each fabric stretched and precisely aligned. The button matrix was constructed by first pre-stretching the fabric on each frame, one for 3D printing and the other for embroidery. The 3D print frame was inserted into the jig, aligning it to later fit in the embroidery machine. We created the button structures on the first layer using 3D printing. Conductive copper pads were attached to the underside to complete the first layer. The circuitry is embroidered onto the second layer using conductive yarn. Using the electronic principles behind the button matrix, we embroidered electric tracks to complete the second layer, separating track crossovers using isolating stitches. The two process layers are combined by assembling the two frames together, allowing for easy alignment as the layers are joined by sewing through both layers. The final combined textile created a button matrix interface which is soft and light, wearable, clickable, pullable, stretchable, and crumpleable, much like your regular textile is. The soft button matrix can be plugged into your Arduino or computer, allowing for soft wearable interfaces which you might wear in the future.